Hey everyone! Welcome back to our C# tutorial series. So far, we've covered variables, control structures, loops, and methods, each of which is a building block for writing great code. Today, we're going to explore another essential concept in programming, arrays. In this video, we'll cover what arrays are, how to create them, and how to use them effectively in your programs. By the end of this tutorial, you'll have a solid understanding of how to work with arrays in C# and be able to apply them to solve more complex problems. So, let's jump right in. Let's start by understanding what an array is. In its simplest form, an array is a collection of variables that are all of the same type, stored in a contiguous block of memory. Each item in the array is called an element, and each element is accessed by an index, which represents its position in the array. Think of an array like a row of lockers. Each locker has a number, the index, and inside each locker, you can store something, the element. Just as you can put different items in different lockers, you can store different values in each element of an array. Arrays are incredibly useful when you need to store and work with a collection of related data. Instead of creating separate variables for each item, like score1, score2, score3, and so on, you can store all these values in a single array and access them easily. Now that we have a basic idea of what an array is, let's see how to create one in C#. Creating an array involves three key steps. Declaring the array, you specify the type of elements the array will hold and the name of the array. Allocating memory, you define the size of the array, how many elements it will hold. Initializing the array, you can assign values to the array elements either during or after creation. Let's create a simple array to store the scores of 5 players in a game. Here's what's happening. Int declares an array that will hold integers. Player scores is the name of the array. New int 5 allocates memory for 5 integers. The number 5 indicates the size of the array, meaning it can hold 5 elements. At this point, the player scores array has been created, but the elements haven't been assigned any specific values yet. By default, numeric arrays in C# are initialized with zeros. If you want to initialize the array with specific values right from the start, you can do so like this. In this case, the array will be automatically created with the values you've provided. And that's it. You've just created and initialized an array. But arrays aren't much use if we can't access and manipulate the data inside them. So, let's look at how to work with arrays. Once you've created an array, you can access and modify its elements using their index. Remember, array indices start at 0, so the first element is at index 0, the second element is at index 1, and so on. Let's see an example. Suppose we have an array of player scores, and we want to print each score to the console. In this code, player scores 0 accesses the first element of the array, 10. Player scores 1 accesses the second element, 20, and so on. When you run this code, it will print. But what if we need to update a score? Let's say player 3 scored 60 points instead of 30. Here's how you can update the third element of the array. Now, player scores 2 holds the value 60 instead of 30. When you print it out, you'll see. This is how you can both access and modify the elements in an array. But what if you want to do something more complex, like looping through all the elements? This is where loops come in handy. Arrays and loops go hand in hand. When you need to perform the same operation on each element of an array, you can use a loop to iterate through the array efficiently. Let's revisit our player scores array. Suppose we want to print all the scores using a loop instead of writing separate console.writeLine statements for each score. Here's how you can do it with a for loop. In this code, we use a for loop to iterate through each element of the array. I is the loop counter, starting at 0 and increasing by 1 on each iteration. Player scores length gives us the total number of elements in the array, ensuring that the loop runs exactly as many times as there are elements. When you run this loop, the output will be the same as before. Using a loop makes your code much more scalable. If you had an array with 100 elements, you could print all of them with just a few lines of code using a loop. Let's take it one step further and sum up all the scores in the array. One common operation with arrays is summing all their elements. Suppose you want to calculate the total score of all players. Here's how you can do it. Here's what's happening. We initialize a variable total score to 0. This will hold the sum of all scores. We loop through each element in the player scores array. In each iteration, we add the current element to total score. After the loop finishes, total score will contain the sum of all elements in the array. When you run this code, it will print. Summing array elements is just one example of what you can do with arrays and loops. You can also find the maximum or minimum value, search for a specific element, or even sort the array. Until now, we've worked with one-dimensional arrays, essentially, lists of values. But sometimes, you need to work with more complex data structures. That's where multidimensional arrays come in. A multidimensional array is like a table or a matrix. For example, if you're storing the scores of players across multiple games, you might use a two-dimensional array where one dimension represents the players and the other represents the games. Here's how to declare and initialize a two-dimensional array. In this example, player scores is a 3 by 3 array. The first dimension represents the rows, players. The second dimension represents the columns, games. To access or modify elements in a multidimensional array, you specify both indices. This will output. Working with multidimensional arrays is very similar to one-dimensional arrays, but you need to keep track of multiple indices. These arrays are particularly useful for complex data structures like matrices, grids, or game boards. Alright, it's challenge time. Let's put your new skills to the test. I want you to write a program that finds the highest score in an array of player scores. Here's what you need to do. Create an array of integers to store the scores. Loop through the array to find the highest score. Print the highest score to the console. As a hint, you might start by assuming the first score is the highest and then compare it with the others. Here's a quick example to get you started. When you run this code, it should output. Give it a try. And if you're feeling adventurous, see if you can modify the program to find the lowest score or calculate the average score. And that's a wrap for today's lesson. We've covered a lot of ground, from creating and initializing arrays to looping through them and even working with multidimensional arrays. Arrays are incredibly powerful tools in C#, and mastering them will make you a much more effective programmer. In our next video, we'll explore another key concept in C#, lists. Lists are similar to arrays but offer more flexibility and functionality. You'll learn when to use arrays and when to use lists, and how to work with both in your programs. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you never miss an update. And as always, if you have any questions or suggestions for future topics, leave them in the comments below. Thanks for watching, and I'll see you in the next one.